Hi, this is a video for grade 10s and we're looking at quadratic relations in vertex form and other forms. Here's the question we're doing. Write the standard form equation of the quadratic relations shown below. So first of all, to write a standard form equation, I first need to write the vertex form equation, and then I can translate it or algebraically manipulate it into standard form. So for now, I'm ignoring the request about standard form, and I'm going to try to write the vertex form equation of this parabola. So we have, it's not even a full parabola, but that's okay because we just need to have the vertex visible, which I can see right here. The vertex is at 10, 55. And we need one other point that I can tell for sure where it is. So I call that a lattice point. And this might be a lattice point, but it's kind of hard to tell because of how thick that line is. Whereas right here, you can see that there's actually a point given on the picture. And that means that's sort of the point that we know for sure is right there. And that is the point that is at 0, 15. So it's a y-intercept. That's nice to know. I like working with 0. Regardless, I need some point, and that's the point. First, however, I need the vertex. So in order to write an equation in vertex form, we remember that vertex form looks like this, where the h and k values tell us about the vertex. So I have a vertex at 10, 55. I made that messier. So this is what I write. X minus 10 squared plus 55. So I've simply put the values of h and k from the vertex directly into the equation. Now I need to find a, and the way that we find a is we take another point on the function or on the relation, and the other point I know is 0, 15, and that gives me an x and a y value that I can use in this equation where x and y are. When I sub numbers in for x and y, the only variable left will be a, and then I can solve for a. So if y is 15 and x is 0, that's the point I know. So I'm going to sub it in and then solve for a. So here I have a times whatever this bracket squared is, and then on the end I'm adding 55. So I'm going to subtract 55. So 15 minus 55 is negative 40. And then I'm going to do this calculation. So 0 subtract 10 is negative 10, and negative 10 squared is 100. So I have negative 40 equals a times 100. So I need to divide by 100 so that I can isolate a. And I would get negative 4 over 10, which actually reduces even further. So I already reduced negative 40 over 100, but that reduces even more to negative 2 over 5. If you wrote negative 0.4, that's good, it's correct. But again, as much as possible, we like to work in the world of fractions. So I took negative 40 over negative 100, and I reduced that fraction as much as I could. So now I can write the equation of the parabola in vertex form. So let me go over here and write that. So y equals negative 2 over 5, and then I have x minus 10 plus 55. X minus 10 squared plus 55. So that's the equation in vertex form. And now I want to turn this into standard form. So this is where we just do our Bedmas algebra. So inside the bracket, there's nothing I can do. So then I find this exponent of 2. And if I apply that squared exponent to the bracket, I'm going to be squaring that binomial. So y equals. So inside this bracket, I will do that squaring of the binomial. So square the first, double the product. Negative 10 times x is negative 10x. If I double that, I get negative 20x. Square the last, I get positive 100. So now I have to multiply by negative 2 over 5 and add 55 What do I do first? Well, I have to do the multiply first. So I'm going to multiply negative 2 over 5 into the bracket. And I'm multiplying by a fraction, so I'm going to take a little more time. You might be able to do this in fewer steps than I'm about to do. So negative 2 over 5 times x squared is just negative 2 over 5x squared. And then I'm going to do negative 2 over 5 times negative 20x. So negative 2 times negative 20 is positive 40, and there would be over 5x. So really I'm taking the numerator multiplied by the numerator, because there's a secret denominator of 1, and I get positive 40 over 5x. Now I'm going to do negative 2 over 5 times 100. So negative 2 times 100 is negative 200. And then that would be over 5. And the plus 55 just sits there. I haven't done anything. So before I actually do collect like terms, I have a couple fractions. And some of them can be reduced. Negative 2 over 5 can't reduce anymore. So I'm going to leave it as negative 2 over 5. But the other fractions can be simplified. Oops. So 40 divided by 5 is 8x. Negative 200 divided by 5 is negative 40. And that's going to make this a lot easier because my final step is always that collecting like terms. So I get y equals negative 2 over 5x squared plus 8x, and negative 40 plus 55 is positive 15. And what's kind of interesting about this is I knew that this had to be positive 15 because the y-intercept was the point that I knew, and the y-intercept, when x is 0, y is 15. Well, when x is 0, this is 0 squared, 0 times this, that's 0, and I'm just at 15. So I'm very glad that that 15 showed up, and that's my final answer in standard form. I hope that helps. Keep practicing.